So this is another question about the step pulley system. So consider a situation given in figure. A string connected to block B is passing through two movable pulleys X and Y and wound on the smaller disc of pulley step pulley. Another block A attached to pulley X. Analyze the constrained motion of blocks A and B, and the step pulley ratio is given as 1:3. It means the radii is given as 1:3. In this case, what we do, rather we assume that let us say that block A moves by X in the upward direction and this pulley Y moves in the downward direction by distance Y, and let us name these strings. We call this as string number 1, this string number 2, and this is string number 3. So we write this as let block A move upward by X, pulley Y moves downward by Y. So because of the movement of block A in the upward direction, pulley X is also going to move upward, and it is going to introduce a slack in string number 3. You can see that as pulley X moves in upward direction, it will introduce a slack in string 3, and this slack, let us suppose, is given as x prime. So we can find out the relationship between x prime and y, okay, because the step pulley radii ratio is given as 1:3. So based on this, we can say that our x prime will be equal to y by 3, and because of the upward motion of pulley X, the slack introduced in the string number 2, okay, the slack introduced in string 2 slack introduced in string 2, it can be given as so this is moving X in upward direction and pulley Y is moving in downward direction. The slack introduced will be given as x plus y, okay, and the slack introduced in string number 1 the slack introduced in string 1 will be equal to y. How? the resulting slag in string number 3 will be dependent upon two things. First, it will be dependent upon y, and second, it will be dependent upon the upward motion of block A. So you can say that there is final slag in string 3 will be determined by the motion of block A and pulley Y. And which can be found out as x minus x prime, and we already know x prime is given as y by 3. This will be x minus y by 3. And we also assume that the block B moves in the downward direction by displacement z. Okay. So let block B moves in downward direction by z. Now we want that this string should have no slack, and it should be perfectly tight. So under this condition, the total displacement of z should be equal to the summation of the individual slags of string number 1, 2 and 3. Okay. So you can say that for slag to be 0 in the entire system of strings 1, 2 and 3, you can say that z should be equal to slack in 3 plus slack in 2 and plus slack in 1. Slack in 1. So if we substitute the values, we can say that z will be equal to x minus y by 3 plus x plus y and plus y. We can further solve it. We can get z is equal to 2x plus 5y by 3, and if velocity of, you can say velocity of block B is given as VB, velocity of block A is given as VA, and velocity of pulley Y is given as Vy. Let us call this equation 1. So differentiating equation 1, we get VB is equal to twice VA plus 5 by 3 Vy. So this is the relationship between the velocity of block A, block B, as well as velocity of pulley Y. Thank you.